We're doing two things today. We're going to solve a system of equations using an inverse matrix, and then we're going to solve systems of equations using Cramer's rule. After today, we will have five.
Did you start that?
After today, we will have 5 ways to solve systems of equations. Before you got into this class, you knew 2. What were those 2 ways?
Elimination.
Before you got into this class.
Elimination.
Substitution and elimination. We've already done Gaussian elimination. Now we've got using an inverse, and we've got using Cramer's rule. So you've got 5 ways to solve a system of equations after today. So we're going to start off with the inverse matrix today. Alright, I have 5x minus 2y equals 11, negative 4x plus 7y equals 2. I want to solve this system, and I'm going to use the inverse of the matrix to do it. First thing I want to do is write it in matrix form. Slightly different than what we've done so far. Okay, write that down, and then I'll explain why it looks the way it does. So 5, negative 2, negative 4, 7, x and y, 11 and 2. Alright, what's going on between these 2 matrices on the left? They're multiplying. How do we multiply 2 matrices? Row by the column. So 5 times x gives me 5x. Negative 2 times y gives me the 2y. Negative 4 times x gives me the negative 4x. 7 times y gives me the 7y. So that's why we're allowed to write it that way. Okay? Alright. Now, if I were to solve something like 3x equals 9, what would we do? Divide by 3. What's another way we could say that instead of divide by 3?
Multiplying by 1/3.
Multiply by a third. Okay, and we talked about that the other day. How are 1/3 and 3 related? They are multiplicative inverses of each other. Okay, what do I get when I do 1/3 times 3? I get 1. What is 1? It's the multiplicative identity. Okay, and anything times 1 is itself. Okay, so I do 1/3 to both sides, and we'd end up with x equals 3. Same concept here. I'm interested in getting that by itself, which means I have to get rid of this matrix. So what do you think we can do to get rid of this matrix?
Multiply the inverse.
Multiply by its inverse. So when I multiply by its inverse, I get the the matrix identity. And since it's identity, that identity times anything else is going to be what? Whatever that anything else is. So the matrix identity times xy is just going to give me xy. So what we want to do is multiply both sides by the inverse of that, and that's going to give me my solution. Okay, so I've got x and y, and then I want to multiply 11 over 2 by the inverse. What's the first step in finding the inverse? Find the determinant. Good. So 5 times 7 is 35, negative 4 times negative 2 is 8, and what do I do with those numbers? Subtract. What do I get? 27. What do I do with 27? Put it underneath 1. Okay, switch the 5 and the 7. Change the signs of the other 2. Alright, so what I have represented right here is the inverse of that matrix. So what should happen is, when I multiply everything out on the right, I'm going to figure out what x and y are. Okay, this 1 over 27, that's the last thing I'm going to deal with. So right now, I want to do this matrix times that matrix. What do we do to check and make sure we can multiply them? the order. So what's the order of this first one?
2 by 2.
And the second one? So what am I going to end up with?
2 by 1.
A 2 by 1. Okay, so there's my 2 by 1. So 7 times 11 is 77. 2 times 2 is 4. 4 times 11 is 44, and 5 times 2 is 10. All right, so 77 plus 4. 81. 81 divided by 27. 3. 44 plus 10. 54. 54 divided by 27. 2. So this means that x equals 3 and y equals 2. So that's using the inverse of a matrix to solve the system of equations. Any questions on what we did there? So wrote it in matrix form, multiplied by the inverse, and cleaned it up.
What happens if you have
Bottom right.
like if you get a 2 by 2 instead of a 2 by 1?
Switch to the bottom right.
You did something wrong.
Okay, so you should always end up with
Will you switch
okay.
The matrices on each side.
The number she's welcome.
If this says equal, then that and that should end up being the same when you finish it. All right, let's look at the 3 by 3.
So,
Negative 3x plus y plus 6z equals 15. 2x plus 2y minus 5z equals 9. And 4x minus 5y plus 2z equals negative 3. So I want to solve this system of equations using the inverse of a matrix. So what do we do first? Write it in matrix form. So negative 3, 1, 6, 2, 2, negative 5, 4, negative 5, 2. X, Y, Z. 15, 9. Alright, now what do I want to do?
You want to find the inverse of the 3 by 3.
I want to do the inverse of the 3 by 3 and multiply it times that. How do we find the inverse of the 3 by 3?
You take the first 2 sections and move to the right.
That's if I find the determinant. How do I find the inverse of the 3 by 3?
Put it back.
You put it in the calculator. Alright.
I'm done.
So I'm going to hit my matrix button.
Yeah, super good.
The first one is a 3 by 3, so I fill it out. So I've got negative 3. I've got 1. I've got 6. I've got 2. 2. Negative 5. I've got 4. Negative 5. And 2. So once I fill out that matrix, what do I do next?
You put it up in the
Raise it to the negative 1 power. So raise it to the negative 1. Okay, and then I'm going to hit times, and I want to multiply it by what? Say that again.
59.
15, 9, and negative 3. I was looking for the wrong one. Thank you, sorry. So, I get my matrix. This time, what type of matrix do I want?
3 by 1.
A 3 by 1. So I put in a 3 by 1, and I do 15, I do 9, and I do negative 3. I press enter. I get 8, 9, 5. So 8, 9, 5 goes there. So that means x equals 8, y equals 9, z equals 5. Yes. Right side.
I'm still doing it. Hold on.
If Brandon up further out.
What?
Alright,
Still doing it.
so that is solving systems of equations using an inverse matrix. Any questions on that side? Alright, let's look at Cramer's rule.
Hey! Figure it out on this. Hey, Brandon. Boy. Yeah.
Okay, we'll do Cramer's rule with the 2 by 2, and we'll do Cramer's rule with the 3 by 3, and then we'll be finished up for the day. So negative 3x plus y equals 4. 2x plus y equals negative 6. I want to use Cramer's rule to solve this. Alright, on Cramer's rule. First thing you want to do is declare what variable you want to solve for. So I can solve for x or I can solve for y. So I need to make that declaration to begin with. So which one do you want to solve for? Alright, so we'll just say we're solving for y. Okay, then I'm going to be dealing with a pretty big fraction. On the bottom of this fraction, I want to take the coefficients that are right there and make a matrix of it. So that is negative 3, 1, 2, and 1. Notice I'm just putting vertical lines around it. If you have a matrix that just has vertical lines around it, that means you're looking for the determinant. So that means I'm only interested in the determinant of that matrix. Second step is, since I am solving for y, I take these values that are on the right of the equal sign and put them in the y column for the top. So I'm going to put 4 and negative 6 in the y column. The other column must match what's on the bottom. So on the bottom, negative 3 and 2, those two must match. So again, why did I put the 4 and negative 6 in the second column? I'm solving for y, that's the y column, so that's where they must go. Now all I've got to do is find the determinant of each of these, divide, and I have the value for y. So negative 3 times 1 is negative 3, 2 times 1 is 2, negative 3 minus 2 tells me my bottom number is negative 5. Do the same thing on the top. Negative 3 times negative 6 is 18, 2 times 4 is 8, 18 minus 8 gives me 10. So I divide 10 and negative 5, that tells me that y equals negative 2. Then I plug that in to solve for x. It does not matter which one I plug into. I'm going to plug into the bottom one. So I plug negative 2 in for y. 2x minus 2 equals negative 6. Add the 2 over. 2x equals negative 4. So we find that x is also negative 2. So The bottom matrix must match the original matrix. The top matrix, the answers on the right side must replace one of the two columns. It replaces the column of the variable you're looking to solve for. Question on that one before we do a 3 by 3?
I don't know how you get the last, like the bottom half.
This
Yeah.
is the coefficients of that.
Oh.
Alright, 3 by 3. Alright, 2x minus 3y plus 3z equals 8. Negative x plus 2y minus z equals 2. And x minus y plus z equals 3. So I want to use Cramer's rule to solve this system of equations. Alright, what's the first thing I want to do? Declare what I want to solve for. It doesn't make a difference. Let's solve for z to mix it up. So we'll solve for z to mix it up. So the bottom has to be the matrix that is right here. I want those coefficients. So 2, negative 3, 3, negative 1, 2, negative 1, 1, negative 1, and 1. Since I'm solving for z, that means 8, 2, and 3 needs to go in column 1, 2, or 3. Which one?
3.
Needs to go in column 3. So 8, 2, and 3 goes in column 3. The other two columns must match the columns on the bottom. So 2, negative 1, 1, negative 3, 2, negative 1. Now all I have to do is find the determinant of each of those and divide. I've got z. So what do we do to find the determinant of 3 by 3?
You put the first two.
Repeat the first two columns. So 2, negative 1, 1, negative 3, 2, negative 1. Alright, 2 times 2 times 3, 12. Negative 3 times 2 times 1, negative 6. 8 times negative 1 times negative 1 is 8, so that gives me 14. 1 times 2 times 8, 16. Negative 1 times 2 times 2, negative 4. 3 times negative 1 times negative 3, 9. So that gives me 21. 14 minus 21 is negative 7. I've got to do the same thing on the bottom. 2, negative 1, 1, negative 1, 2, negative 3. 2 times 2 times 1, 4. Negative 3 times negative 1 times 1, 3. 3 times negative 1 times negative 1, 3. So that's 10. 1 times 2 times 3, 6. Negative 1 times negative 1 times 2, 2. 1 times negative 1 times negative 3, 3. So that gives me 11. So 10 minus 11 gives me negative 1. So that means that z equals 7. So this one's got 3 variables, so that means I have to do that one more time. But what do I not have to do again?
On the
Find the determinant of the bottom, because the bottom's always going to be the same. So the only thing I have to find the determinant of is the top for x or y. Alright, so let's do the top. Let's do the top for x. So I know the bottom is just going to be -1. So if I'm solving for x, that means 8, 2, and 3 need to go in which column? First column. So we need 8, 2, and 3. -3, 2, -1, 3, -1, 1. Repeat my columns, 8, 2, 3, -1, 2, -3. Alright, so 8 times 2 times 1, 16. -3 times -1 times 3, 9. 3 times 2 times -1, -6. So that gives me 19. 3 times 2 times 3, 18. -1 times -1 times 8 is 8. 1 times 2 times -3, -6. So that gives me 20. 19 minus 20 is -1. Divided by the -1 that was in the bottom, that tells me that x has to be 1. Once I have two variables, then all I've got to do is plug it in to find the third. It does not matter which equation I plug into, which one of those three looks the easiest to plug into. The bottom. So, plug 1 in for x, minus y, plug 7 in for z. So 1 plus 7 is 8. I subtract 8 over. Negative y equals -5, and that means y equals 5. And I have solved that system of equations. So that right there is using Cramer's rule to solve the system of equations, and earlier we used the inverse of a matrix to solve the system of equations. Alright, your assignment is 392, 2 to 8 even. 2 to 8 even is where you're using the inverse, and 12 to 18 even is where you're using Cramer's rule. The only two problems you're using your calculator on with the matrix is 6 and 8.